Good morning, dear student. Today I am going to discuss about the various rules and the guideline about the IUPAC nomenclature of organic compound. All of you just look to the slide. There have various types of examples with their name, that is alkene, aldehyde, monohydrate alcohol, homologous series, ketones, carboxylic acid, etc. with their structural formula and whatever their root word, primary suffix, secondary suffix, and the final IUPAC name. I think if any students can remember this chart according to the rules, they can easily write down any IUPAC name of an organic compound. So let's start from the first compound, that is alkane. Alkane, also called paraffin, and its general formula is CnH2n. N means 1, 2, 3, 4, 5, 6, 7, 8, dot, dot, dot. And why alkane is called paraffin? Because all alkane compounds are stable, and paraffin means the uh, compound which is very stable in nature, and the paraffins compound are generally attached by a single bond, that is saturated compound, and alkane also follow these rules. That's why paraffin also called alkane. And alkenes are also called olefin. The general formula is CnH2n. So at first I discussed about the structural formula of alkane. I already told you that the all alkane compound are joined by a single bond. That's why when you going to nomenclature of any alkane compound, so then you have to add any add suffix for a saturated compound. And in case for alkenes and alkynes, so what happened? In case of alkene, if any compound is unsaturated and contain double bond, then you have to add primary suffix, that is ene. So I think all of you can remember that what I say in my previous lecture video. That is, at first you have to remember how much carbon atom are present in the compound. This is root one. Then you have to identify that the compound is saturated or unsaturated. After that, you have to identify that any functional group are present in this compound or not. These three things is very important to write down any uh, IUPAC name of organic compound. So, in case of alkene, you just look to the example. Okay, I just tell about the first example, that is ethene. They have two carbon atom connected by double bond. That's why eth for two carbon atom or ene for double bond. Okay, it's called ethene. Next, the compound is propene, which contains three carbon atom. Okay, next is butene. It is contain four carbon atom. One thing we have to identify from these four examples, that you have to start the numbering from the carbon atom which contain double bond. Okay, you just come to these two example, in between two example, that is, in the first example, I start the numbering from right side because this carbon atom contain double bond. Okay, that's why I start numbering from right side. In next example, the double bond present in the middle position. Okay, so I can start from this numbering left side, but unfortunately there have a mistake that I start the numbering from right side. But I think all of you all don't forget these things, that when you notice that any compound contain double bond or triple bond or any functional group, or it may be any alkanes compound, that's mean the saturated compound, you always obey the general formula. That's mean যখন তোমরা দেখবে যে ডবল বন্ড মধ্যিখানে প্রেজেন্ট হয়েছে বা এমন একটা জায়গায় পজিশন রয়েছে যেখানে তুমি ডান দিক থেকেও করলেও তোমার তুমি ডবল বন্ডকে যে নাম্বারিং এ ফেলতে পারবে, বাঁ দিক থেকে করলেও তুমি সেই ডবল বন্ড সেই নাম্বারিং এ ফেলতে পারবে, তখন কিন্তু তুমি সবসময় চেষ্টা করবে বাঁ দিক থেকে নাম্বারিং করা। আমি এখানে লিখতে একটু ভুল করেছিলাম, তো আমি সেটা আমার আর কারেকশন করা হয়নি, তো কিছু মনে করো না, তোমাদেরকে আমি জিনিসটা বলে দিলাম। So now come to the alkynes. That means the general formula CnH2n minus 2. Alkynes are also called acetylines. Alkynes means the organic compound contain triple bond. So same as alkenes, you just look the example. Okay. Now come to alcohol. General formula is CnH2n plus 1 OH. OH means the hydroxyl group each state that the compound is alcoholic in nature. So if any OH group or hydroxyl group attached with a single carbon compound, it's called methane. There have an example. If ethyl group attached with the alcohol group, it's called ethanol. And if carbon atom, single carbon compound attached with hydroxyl group, is called methanol. So single carbon atom meth and primary suffix an, ane and secondary suffix on. তাহলে অ্যালকোহলের জন্য কিন্তু সেকেন্ডারি সাফিক্স হবে অন, মানে কি যখনই ফাংশনাল গ্রুপ হয়ে যাচ্ছে তখন কিন্তু তিনটে ওয়ার্ড মিলে একটা নাম, যেরকম মিথ ফর সিঙ্গেল কার্বন অ্যাটম, N for saturated compound, and all for alcohol group. So if we combine these three names, the final name is methanol. Similarly, for ethanol, two carbon atom are present here. So if N for saturated compound and al for alcohol, it's called methanol. So similarly, the propanol, propane 1 al. Okay. So why this is methanol, ethanol, and why it is propane 1 al? Because when more than two carbon atoms present in a compound and this compound contain any functional group or alcohol group, so we have to identify the alcohol group attached with which number of carbon atom. If the alcohol group attached with the first carbon atom, so then, and obviously the first carbon atom according to the numbering. Okay, so if you notice that the alcohol group present on the first carbon atom from right side or from left side, then you have to identify that uh, the left side carbon atom are counted as number one, and if the alcohol group present at the last, that left one carbon atom, then you have to start the number from the last left carbon atom as one. So then it just as a propanol. Okay, but in case of IUPAC, you have to write down that which carbon atom contain second bond, sorry, double bond, triple bond, or any functional group. That's why when you giving a numbering, or when you are going to nomenclature of a compound contain more than two carbon atom, then you have to write their name just like this. That is, in this from this example, I just told you that I just start numbering from the right side because this right side carbon atom contain an alcohol group. So that's why prop N one, number one position, alcohol group is attached. then it's called propane 1 al. Next example, you just look that the alcohol group attached with the second carbon atom. So this is same prop ANE for saturated compound and all for alcohol group, and you write the name is propane 2 all because the alcohol group attached with the second carbon atom. So this is the example of alcohol. Next come to the aldehyde. These all things are same if aldehyde group attached with the last one carbon atom from both right side or the left side, then you have to start the numbering from right side or the left side. But if you notice that the aldehyde group is in the middle position of carbon atom, then you have to uh, count that the which number is near or near to the functional group, or which number is very শর্ট অর মানে যেটা আমি বলতে চাইছি যে কোন নাম্বারিংটা অ্যালডিহাইড গ্রুপটাকে সবথেকে কম জায়গায় দেখাবে সেটা তোমাকে আইডেন্টিফাই করে সেই হিসাবে কিন্তু নাম্বারিং করতে হবে। তো সিমিলারলি it is applicable for all like ketone, carboxylic acid, acid chloride, acid amides, amines, cyanides, alkyl halides, and at least ethane. Okay, so this is the end of the nomenclature of organic compound as per IUPAC rules. Now, next to the now come to the next slide. That is isomerism. What is isomerism? I think all of you have some idea about isomerism. That is, if any compound, if any two compound have similar molecular formula, but their physical chemical property is different, it's called isomer. Generally, তাহলে আমি কি বললাম না, আইসোমারিজম বা আইসোমার কি জিনিস না, আইসোমার মনে হচ্ছে যদি দুটো কম্পাউন্ডের মলিকিউলার ফর্মুলা সেম কিন্তু তাদের কেমিক্যাল এন্ড ফিজিক্যাল প্রপার্টি আলাদা, তখন ওই দুটো কম্পাউন্ডকে একে অপরের আইসোমার। আর এই যে পুরো জিনিসটাকে বলবো আইসোমার। ফিজিক্যাল কেমিক্যাল প্রপার্টি আলাদা হচ্ছে, তার মানে ওদের মধ্যে কার্বন কার্বন বন্ড the presence of functional group is different, whatever may be the same molecule. Generally, the isomerism are two types: structural isomerism and stereoism. What is structural isomerism? And I just discussed about the structural isomerism as per your syllabus. I do not discuss about the stereoisomerism because stereoisomerism are not in your syllabus. So what is structural isomerism? Structural isomers are those compounds which have same molecular formula but differing assigned or arrangement of carbon atoms. So what I say about structural formula? Structurally different. That means for a long chain compound, a methyl group attached with the second number of carbon atom on the left. So that means the long chain carbon atom contain a substitute of alkyl compound. Similarly, if a compound is attached with each other in a continuous way, that means the substituent compound and the long chain compound contain same carbon atom and same hydrogen, but they are structurally different. That's why it is called structural isomerism. Just come to this picture. Here I give two examples. That is painting. That means this compound contains five carbon atoms. One, two, three, four. And in this compound also contains five carbon atoms. One, two, three, four, five. One thing I just want to say you, structural isomerism or stereoisomerism, whatever may be the isomerism, it always depend on the general nomenclature, not on IUPAC name. ঠিক আছে, তাহলে জেনারেল নোমেনক্লেচারে আমাদের কি দেখতে হবে, আমাদের কি ছিল যে কটা কার্বন অ্যাটম আছে সেইটা আমাদের দেখতে হবে, আর সেটা স্যাচুরেটেড না আনস্যাচুরেটেড সেটা আমাদের দেখতে হবে, আর কিছু আমাদের দেখা দরকার। ঠিক আছে, তো সেই হিসাবে এটা হচ্ছে পেন্টেন, বাট this compound also contain five carbon atoms, but a substituent that is the alkyl on a methyl group that is CH3 attach just the above of this carbon atom. That means is two number of carbon atom from the left side. That's why it is pentane, it is isopentane. And this pentane or isopentane are isomer of each other. There have a picture, you just notice that this is butane. Okay, one, two, three, four. And when one methyl group is attached from here and attached with this carbon atom and the hydrogen present here is going to these sides, it is formed isobutane. Okay, so butane or isobutane are isomer of each other. Generally, structural isomerism have six subdivision. মানে structural isomerism ছ ভাগে ভাগ করা যায়। First one is chain isomerism, second one is positional isomerism, third one is functional isomerism, next is metamerism, tautomerism, and revisionism. So come to the subclasses of structural isomerism. What is chain isomerism? Now, when two or more compounds having the same molecular formula and family but differ in carbon skeleton are called chain isomerism, and the phenomenon chain isomer, and the phenomenon is called chain isomerism. So this is my previous example, that is pentane and isopentane, and this pentane or isopentane are chain isomer of each other. Next, come to the positional isomerism. What is the positional isomerism? Now, when two or more compounds having the same molecular formula and belonging to the same family. Same family means the both compounds which have same molecular formula have uh, double bond. And that means the two compounds which have same molecular formula contain one double bond or one triple bond, or they belonging from alcohol compound. But the presence of functional group or the presence of double bond or triple bond is different in between two compounds. Just like my first example, that is but 2 ine and but 1. So here in but 1 ine, the triple bond attached with the first carbon atom from left side, which another carbon atom. But in but 2 ine, the triple bond are present in just middle of this compound. So if I going to the numbering of this compound, so I can put the number from left side and as well as from right side, whatever may be, it is but 2 wine. And now come to the alcohol. Okay, there alcohol group present in the first carbon atom from the right side, and in the second example, the OH group attached middle carbon atom of this compound. That is, but this one is isopropyl alcohol. The first one is N-propyl. So next, come to the ring chain isomerism. Compound have same molecular formula but possessing open chain and uh, open chain and a closed chain, that is the ring chain structure, and known as ring chain isomer. And the phenomenon is called ring chain isomer. So what I say about the ring chain isomerism? The ring chain isomerism means if any compound contains four carbon atoms with a double bond, which is butene. Similarly, when these four carbon atoms are attached with their cyclic bond, it is called cyclobutane. So in this butene and the cyclobutane, the molecular formula is same, but they are totally different in nature. Similarly, in case of propane and cyclopropane, and for cyclobutane and methyl cyclobutane. So in this cyclobutane, there have four carbon atoms, and in this methyl cyclopropane, so, what happened? A methyl group attached with a carbon atom and present in this molecule as a substituent. So that's why this cyclobutane and methyl cyclobutane are isomer of each other. So I think it is clear to all of you about the rich and isomerism. Now come to the functional isomer. Functional isomerism means compound having same molecular formula but contain different functional groups is called functional. So here, what I say, if you notice that the two compounds have same molecular formula, but two different functional groups are present on the both compound, which called functional isomer of each other. So just come to the first example, that is C2H6O. So this is ethanol and this is dimethyl ether. So in case of ethanol, you just look the presence of carbon and hydrogen and oxygen. It's similar as dimethyl ether, but this is ethanol contain alcohol group, and is in the dimethyl ether there have a ether group. That's why it is uh, functional isomer of each other. Similarly, for propone and propanol, because it is the ketone group and it is a aldehyde group. Okay, but they are have same molecular formula but contain two different functional groups. So this is the functional isomer, and the phenomenon is called functional isomer. Now come to the metabolism. What is the metabolism? A compound having same molecular formula but different substituent or different alkyl group attached to the same polyvalent functional group are called metabolism. So at first I discussed about the first example about the metabolism. Suppose a ether group is here, and this ether group contains two ethyl groups on both sides. But in the second part, the ether group contain methyl group in the left side and propyl group on the right. But if we calculate the molecular formula, it's said for these two compounds, but the name and physical and chemical properties is totally different from each other. Clear about the metamerism. So what I say about the metamerism, না যখন কোনো ফাংশনাল গ্রুপের দুদিকে অ্যাটাচমেন্ট থাকার কথা, যেরকম কিসের হয়, কিটোনের হয়, ইথারের হয়, ঠিক আছে, আর কিসের হতে পারে না তোমার তোমার হচ্ছে অ্যালকাইল সাবস্টিটিউট হতে পারে, অ্যাসিড হ্যালাইডের হতে পারে। তো এরকম যে সমস্ত ফাংশনাল গ্রুপে দুই ধরে দুটো অ্যাটাচমেন্ট বা সাবস্টিটিউয়েন্ট থাকতে পারে, তো সেই সমস্ত ফাংশনাল গ্রুপের ক্ষেত্রে যদি দুই ধারে দুটো ভিন্ন ধরনের সাবস্টিটিউয়েন্ট থাকে এবং ওই দুটো এবং যদি এই সময় এরকম হতে হতে অন্য দুটো কম্পাউন্ডের মলিকুলার ফর্মুলা সেম হয়ে যায় তখন একে অপরের মেটাবলিজম বলবো। Similarly, diethyl ketone and methyl propyl ketone. So this ketone group, in the ketone group bonded to ethyl group on both sides. But in my right side, there have uh, a methyl group on the left side and a propyl group on the right side. So this diethyl ketone and methyl propyl ketone is metamer of each other compound. Now come to the tautomerism. So what is tautomerism? These types of isomer in which a substance exists in two readily interconvertible different structure. So what is interconvertible different structure? When I going to the next unit, that is the unit 2, there have a topic that is conjugated time. So in this conjugated time, I discuss more about this interconvertible of any atom of a compound. Interconvertible মানে হচ্ছে যে তোমাদের কিছুটা হয়তো আইডিয়া থাকলেও থাকতে পারে যে যখন কোনো ডবল বন্ড থাকে সেই ডবল বন্ড কি হয় না খুবই তো মানে কি বলবো ভেরি অ্যাক্টিভ ডবল বন্ড বা ট্রিপল বন্ড মানে আনস্যাচুরেটেড কম্পাউন্ড খুব ভেরি অ্যাক্টিভ হয় তো কি হয় ওই যে পাই বন্ডটা ইজিলি ভেঙে যায় এবং ইজিলি ভেঙে গিয়ে কি হয় সে ওই কম্পাউন্ডের মধ্যে থাকা কোনো লেস ইলেকট্রোনেগেটিভ কম্পাউন্ডকে অ্যাটাচ করে বেসিক্যালি হাইড্রোজেন shows this nature. That's why I give the example of acetone. So you all of you know that the oxygen is more electronegative than hydrogen, and in the acetone, oxygen contain a double bond. If this double bond is break, then a positive ion is generated on the head of oxygen. That means there have a less electron. So what will do oxygen? The oxygen want to stable. For this purpose, they attract a hydrogen from other side. So when they attract hydrogen from other side, hydrogen are less electronegative than oxygen. So what? The hydrogen just attached with the oxygen by a single covalent bond. And for the stability of this compound, another double bond is formed where na a where have the hydrogen. তাহলে আমি কি বললাম না অ্যাসিটোনে তুমি দেখো অক্সিজেন ডবল বন্ডের সঙ্গে যুক্ত হয়েছে তো ওই অক্সিজেনে যখন ধরো ডবল বন্ডটা খুলে যাবে একটা বন্ড যখন খুলে যাবে তখন কি হবে না অক্সিজেনের উপর একটা পজিটিভ আয়ন আসবে দ্যাটস মিন ইলেকট্রন ডেফিসিয়েন্ট তখন কি করবে না অক্সিজেন নিজেকে স্টেবল করার জন্য কম্পাউন্ডের অন্য কোথাও থাকা হাইড্রোজেনকে নিজের দিকে অ্যাট্রাক্ট করবে অক্সিজেন তোমরা জানো যে মোর ইলেকট্রোনেগেটিভ দেন হাইড্রোজেন তাহলে অবশ্যই বাধ্য হাইড্রোজেনে কিন্তু অক্সিজেনের কাছে যেতে হবে এবং সে গিয়ে অক্সিজেনের সঙ্গে একটা সিঙ্গেল বন্ড এবার যখনই হাইড্রোজেন একটা কার্বন অ্যাটম থেকে চলে গেল তো সেই কার্বন অ্যাটমের কি হলো না সেই কার্বন অ্যাটম আর বিকাম আনস্টেবল and this carbon atom want to be stable so what they do they form a double bond তো সেরকমই হয়েছে এখানে অ্যাসিটোনে থেকে যখন একটা হাইড্রোজেন চলে যাচ্ছে তখন নিজেদের মধ্যে ইন্টারচেঞ্জ হয়ে বন্ডের ফর্মেশন হয়ে প্রোপেন বা প্রোপ 1E তৈরি হচ্ছে so the acetone and prop 1E is tautomer of each other and at least thank you to all of you for watching my video of the class lecture I think all of you understand my today's lecture, and if any doubt will arise, you obviously ask me, and obviously tomorrow I will give a assignment on the nomenclature of organic compound. So I think all of you just fill the assignment and submit me within due date. Thank you. Thank you all.